So once let's brief up like what we have discussed in our previous sessions and what are we going to discuss in this session. Let's have a look into it. Yeah, let me share my screen. I hope my screen is visible, and I hope you have also watched the previous session recordings so that you will be in sync with me, like what I'm going to discuss today. Okay, anyways, let me show you like what I'm going to discuss today. So basically, we have started with what do you mean by assertion, and we have seen like what exactly an assertion is going to do, like who is going to write this particular assertion, and what is this assertion going to check and verify, right? And next we have started with like one scenario we have took, and we have seen like how exactly assertion is helping us to validate the particular condition. And next, we have seen about this particular time slot. I mean, event scheduler of the system Verilog, and we have discussed about event scheduler of system Verilog. And next, we have started with something known as immediate assertions, and we have tried to understand what do you mean by immediate assertions, right? Now, let's start with let's move forward with this assertions, and let's continue with other kind of assertions. And before that, let's have a scenario over here. Let's say if I'm going to have this particular code with me. So I have declared a simple model where I have two blocks, actually three blocks. One is assign block, and another is always underscore combinational block, and another is initial block. So these three blocks will be running parallelly, right? Now, what do you think I am going to get my result? Whether my output will be pass or whether I am going to get my output as to be fail. Anyone wants to answer this particular question? So what will be my answer? Whether it will be pass or whether it will be failed. Once look into this code. So we have written assign b is equal to not of a, and within an always com, we have written assert b not equal to a and display pass. If this assertion is getting passed, then we are going to display this. Else we are going to display fail. And within an initial block, I'm just applying the input variables as a is equal to 1, and after some time a is equal to 0. So this is what the code is. Now anyone wants to answer like whether we are going to get the pass message or whether we are going to get the fail message? What do you think? Whether the assertion is going to get passed or whether the assertion is going to get failed? Simple question. You can take your time, think about it, and you can answer in the chat box. Okay, pass. So why we are saying it as pass? Because we can clearly see over here assign b is not equal to a. That means a value we are complement of a value we are assigning it to b, and we are checking over here, right? And a value is 1 and a value is equal to 0. So we think that this particular code will be running, and we will be getting pass message. Let's see what is that we are going to get in our compile. So I'm getting pass message, okay, but I'm also getting one fail message, right? Can you see here? And let's say if I want to mention the see the time at which particular time it is getting failed, t is equal at time t is equal to percentage t comma dollar time, okay. And here also at time t is equal to percentage t comma dollar time. Let's see what is the time it is getting passed and what is the time it is getting passed failed. So you can see at the same time slot t is equal to 0, I'm getting two messages. One is pass and another is fail. Anyone wants to answer this? Like why we are getting two messages at the same time slot? What may be the reason for this? So at the same time slot, I'm getting two messages. One is pass and another is fail. So at time t is equal to 0, it is getting fail. And at time t is equal to 0, immediately it is getting pass. What may be the reason for this? Exactly. So all the blocks over here are going to run parallelly. Here always block, initial block and assign block are going to run parallelly. Even before the assignment is made to the variable B, what is going to happen? The assertion is going to check start parallelly, right? So this assertion is going to get failed initially at time t is equal to 0. And immediately at the same time slot, the assignment was made. The complement of A was being able to store in B, so that's the reason here we are getting the pass message. So initially we are going to get fail message because this two are running parallelly and this two are running in which region? Can anyone tell me? Always block and assign block are running in which region? In the active region. Okay, so in the active region, these two are going to run. And what is happening? So in the active region, I'm getting fail message, and at the same active region, the assignment is happening. So that's the reason. Again, I'm getting the pass message. So to avoid this kind of things to be happening, so I'm going to use some operator which is known as hash zero. So this hash zero is nothing but it is going to make sure that this kind of assertion checking is going to happen in the inactive region. So let us run it and let's see what is it we are going to get. See, so pass at time t is equal to 0, pass at time t is equal to 10. So this, if we are going to give hash 0, it will make sure that after completing this particular assignment only, assertion is going to be checked. So this is how we are going to use this hash 0. And this is known as deferred immediate assertion. Deferred immediate assertion. That's it. So this is the difference between your deferred immediate assertions and immediate assertions. Is it clear, guys? Any doubts or any queries? No, no. It will not execute at NBA region. Okay. Yeah. Now, give me a second. Yes. Now let's move forward and let's, even though we have zero delay, it will execute in the active region. Not exactly in the active region. We have seen inactive region, right? So there, that particular thing will be evaluated. Now let's see other kind of assertions. So we have something known as concurrent assertions, right? So in the case of my concurrent assertions, so yeah, and this particular concurrent assertions check the behavior across multiple clock cycles. Okay, so these are evaluated continuously with respect to a clock. Okay, basically in the case of my immediate assertions and deferred immediate assertions, the checking was happening at that particular instant. Like I have shown you previously also, right? In the previous example when we were discussing that particular point, where let's say suppose if I am going to write down assert a and B. So what is going to happen if A is equal to 1 and B is equal to 1, the condition if it is true, then this assertion is going to get passed. Like let's say suppose if I have a particular protocol like if request is equal to 1, then after 10 cycles, my grant should be equal to 1. This is if it is my requirement. Then this kind of checking, I cannot use immediate assertions. Then this kind of checking, I cannot use immediate assertions. In this kind of checking, I am going to use something known as concurrent assertions, right? So this concurrent assertions can have delay based checking. So I can basically check for multiple cycles, right? So basically concurrent assertions check behavior across multiple clock cycles. And these are evaluated continuously with respect to a clock. In the case of your immediate assertions, you cannot check your assertions with respect to clock. Okay. And these assertions are based on sequences, properties, and temporal operators that we are going to discuss. What do I mean by this and all, right? Now, why do I need this concurrent assertions? Suppose, yeah, this is what the example I have shown you over here, request and grant example. Okay. Is it clear, guys? Yeah. Now, so how I'm going to have this concurrent assertions? So concurrent assertions, if you want to distinguish between with your immediate assertions are going to look like this: assert followed by whatever the condition you're going to have. That particular condition you're going to write it down. This is nothing but your immediate assertion, right? But if you want to write down your concurrent assertion, you're going to use a keyword assert followed by property followed by condition.
Hello.
So, yes. So this is nothing but my difference between your immediate assertion as well as your concurrent assertion. In the case of your concurrent assertion, you're going to write down assert property followed by the condition. Whereas in the case of your immediate assertion, you're going to write down assert followed by the condition, right? And if you see a keyword which is known as property, then you should find it out as it's a concurrent assertion, right? So this is a difference between your concurrent assertion and immediate assertion. Now, so in the concurrent assertion, we will have something. One second. Yeah. So in the case of my concurrent assertions, I'm going to have something known as clocking events and sequences, properties, and assertion statement. These are all the components which I'm going to have in the case of my concurrent assertions. Whereas in the case of my immediate assertions, I was just writing down the assert keyword and I'm going to write down whatever the condition which I want to check. That's it. But in the case of my concurrent assertions, I'm going to use something. Okay. So let's see what I'm going to use here. So first one is sequence. So basically, a sequence describe a pattern of signal behavior over the time. Like we have seen, right, request and grant. So if you want to write that particular condition, you can write it down inside a block which is known as sequence. Okay, so you're going to write down sequence and followed by sequence name. This is my sequence name which I'm going to write down. Okay, and this is my keyword which is known as sequence. So basically sequence is nothing but it's kind of a mathematical expression. You're going to write down whatever the, not only mathematical expression, whatever the timing behavior you're going to have, right? So that you can write it down inside a sequence. Okay, and so a sequence is nothing but what sequence of events should occur. That is nothing but your sequence. Okay, now and we will have something known as property. Okay, now ultimately we are going to write down any condition for checking, right? So if we are going to write down in an immediate assertion assert a and b directly, the condition we are writing it down, right? But in the case of my concurrent assertions, instead of writing down this condition directly with my assert keyword, what I'm going to do is I'm going to write whatever the condition I was having, right, that inside a sequence. Okay, so what I'm going to write down, so sequence SCQ is my sequence name. And what is the condition? Have A logical AND with B and the sequence. So this is the relation or whatever the condition I have, I've written inside a block which is known as sequence. Now, what I will do inside my concurrent assertion. So assert and concurrent assertion is going to have a keyword which is known as property. Property. You can directly write down the condition over here as A logical AND with B, or else you can write it down assert property. You can write down the sequence name SEQ. So there are two ways to write down your concurrent assertion. Either you can mention, one second. So either you can mention the condition directly with your assert keyword, or else you can write down your condition inside a sequence and you can basically mention the name of the sequence with your assert. So why we are going to use a sequence, the significance of sequence, we might not understand now, but moving on, if we are going to have complex situations or complex timing behaviors, sequence will be very, very helpful, right? So, and for code optimization, all your sequence will be very, very helpful, right? Yes. Is it clear, guys? Any doubts and any queries up to here? Sequence and assert property and all. So number of conditions are there. Exactly. So whatever the timing behavior you're going to have, right, that you're going to write down in your sequence. And you cannot directly, what to say, you cannot directly have the assert keyword, use it with your sequence. You need to uh, use this assert property followed by the sequence. Like this, you need to write it down. Okay. Yes. Now, what is a property? So we have seen this property, right? Over here. Okay. We can also have something known as property. So basically, a property is nothing but it is going to define in a verification rule using sequences and logic relationships. So basically, a property is nothing but what condition should always hold true. That is nothing but my property. So basically, if I want to tell you what exactly and how you're going to use your property, so you can directly write down property and property name and followed by whatever the condition you're going to have, that condition, and followed by end property. So this is also one kind of block you're going to have where it is also going to contain the direct relation. Or else you can have the property block declared, and inside this property block you can write down whatever the sequence you are having, right? What is the sequence SEQ and followed by end property. Sorry, here you cannot use sequence directly. So this, whatever the sequence you have declared, right, that should be declared inside your property. And then you need to assert this property. Assert property followed by property name PPT. Okay, let me show you the rules over here. So basically, if you want to have the condition directly, you can write down assert property, whatever the property or whatever the condition you are having, you can write it down directly. This is way one, step one. Or else you can basically have that particular expression declared inside your sequence. This is sequence and followed by the condition and followed by end sequence. And you cannot directly assert this particular sequence. You need to include it in a property. You need to declare a block which is known as property and give the block name. And you include this, whatever the sequence you are having, right? You include that inside your property block and followed by end property. Now what you're going to do, you cannot basically uh, use assert keyword with your sequence. You should use the assert keyword with your property. So I'm going to write down assert property and the property name is PPT. So this is how I'm going to use it. Or else sequence is not mandatory. If you think sequence is not needed, you can skip this part and you can write down whatever the direct relation you're having, property PPT, and what is the relation you're having, A logical and with B and the property, right? And you can basically write down assert property and followed by PPT. You might be confusing like what is this property, why is this sequence, like why should I use this sequence, why should I use this property, but trust me, it will be cleared like when you're going to when I'm going to make this things complicated, like if we are going to have complicated relationships or timing relationships, this sequence and property will be very very helpful, right? In those particular cases it will be very very helpful. I will show you that. So for now, just understand that we have some block which is known as sequence and other block which is known as property. And if you want to assert anything, you are going to assert directly. You can use the assert keyword directly with your property, but not with your sequence. That's it. Is it clear, guys? Yes or no? Yes. Yeah. So that's about this particular concurrent assertions and immediate assertions and deferred immediate assertions. Yes. So with this, we have completed this particular session. And if you have any doubts or any other queries you wanted to discuss, you can stay